Hiya, so welcome back. Today I'll be solving Edexcel A Level Physics straight line exam questions. So these questions are from past exam papers, and I've tried to take out the questions which focuses only on the learning that we have done so far, that is using the equation of motions and the graphs. Let's see. Okay, let's just start. If something else comes from somewhere else, I'll just skip it and let's learn something. Okay, let's see. The first one, road trains are used in Australia to transport freight across large flat countries of the country. They consist of minimum 3 trailers connected to a cab, blah blah blah. So we're not interested in this information. This is just building up the background context. The braking distance of a road train tries this speed is this much. So when it travels, so there are two cases. Case one, when it travels with 15 meters per second. Okay, when the starting speed is 15 meters per second, it stops in 70 meters. Okay, assuming that the same braking force is applied at all speeds. So if the braking force is same, force produces acceleration. So assuming acceleration is constant. So here's our hint. So we have to use a SUVAT. Okay, so A is constant. Okay, so that the braking distance of a road when traveling at 25 meters per second, so case 2, if the starting speed is 25 meters per second, the braking distance is 190 meters. Obviously, because it's a braking distance, the final speed has to be 0 in both the cases. So what we're going to do is we are going to find acceleration from here, and you can plug it here and see what distance comes. Okay, so we're just going to use the equation. I'm going to just work it here. Case 1. So v square equals u square plus 2as 0, 15 squared plus 2a70 minus 225 is equals to 140a. So my acceleration is minus 225 divided by 140, which I have a calculator here. Let's just see what this gives you. So 225 divided by 140 is around 1.61. So my retardation is minus 1.61 meters per second square. Now I'm going to use this acceleration in the case 2 and figure out whether the braking distance comes out to be 190 or not. So I'm using case 2, same equation, and so this is 0, final speed, u is 25 squared, 2 times minus 1.61 times s, so times s. So I'm just going to simplify this. This becomes 625. 25 squared is 625. Minus 165 equals to 2 times 1.61, so 2, 12, and 3, 30. So 3.22. You can of course just try and figure out yourself. Minus 3.22 s. So my s comes out to be 625 divided by 3.22 is, it's coming around 1. Yeah, so it's coming around 194. So it is around 190 meters. All right, so this is a simple exam question, and as you can see, it's 3 marks. So what they're looking is whether you can apply one learning. What's the one learning they want you from here is whether you can understand that the acceleration is same in both the 2 cases, and then you calculate acceleration from one case, plug it into second, and find out the distance. That's about it. Okay, let's try another one. A car accelerates uniformly. So again, constant acceleration. That means I can apply my SUVAT as it passes a stationary road train. So, okay, so there is a stationary road train. So there's a car passing by. Okay, the initial speed of the car is 39. So this is 39. And it reaches the speed limit of 130 as it passes the front of the cab. So the minute it passes here, its speeds becomes 130 kilometers per hour. So do you see? So what they've done here is they have created a first step for you. They convert this 130 kilometers per hour into meters per second. Kilometers is times 1000, hour is divided by 3600. So this converts into meters per second. Once you have, I'm just going to do that right away. What is, all right, come on, open up. Okay, so I'm just using 130,000 divided by 3600. So that is around, okay, and then calculate the length of the road train. So what do you think? Which formula should we be using? If you have an initial speed, you have the final speed, what formula do you think you should be using? What do you think? Yes, that's right. So we should be using v squared equals to u squared plus 2as. So I'm just going to use v squared equals u squared plus 2as. Oh, sorry, this is 30. Okay, and so my initial speed is 30 squared. Acceleration is 3.7, and what was my final speed? So my final speed was around 36.11 meters per second. I guess I'm just going to take that as 36 squared, and this is s. Okay, so now I'm just going to figure it out. So 36 squared, or you can just take the entire 36.11 squared and then do it, minus 900 equals this, divided by 2 divided by 3.7. So I'm getting s as 53.51 meters. So I'm just, or so now I might get a little error because I have done some approximations here. Idea is that you use this whole thing and square it, so that you do not do less approximations, hence less errors in your answer. This is what Edexcel prefers. They don't want you to have more errors in your answer, and that's how even the science is. You do not want more and more errors. So instead of taking 36, just do this and then square it and then get the value. Let me just do that. Let me just see what answer it gives me. That gives me here, so 30, I have 13,000. Okay, by all means you can do along with me, so that you do not waste your time. Okay, so I'm just getting this, minus 900 divided by 2 divided by 3.7. So I'm getting answer as around, so if I'm using this whole square, then my answer is coming as 54.6 meters. So do you see how the difference of errors? So advice, do not do calculations in between for the last step. Leave your calculations till the last step. So here, instead of just approximating this and then squaring it here, would increase the error in your answer. Okay, let's just do next one. Question number 2. The photograph shows a motor racing car. Said the curved part is semicircular. The car makes electrical contact with the track using metal brushes. Fine, I'm not interested. Let's just say the following measures are made if a car starting at rest. Okay, so now that's important. So u is 0, starting at rest. Distance traveled 1.2 meters, time taken 0.7, so that the final velocity of the car is about 3 meters per second. So I'm going to just use, because acceleration is constant, I'm going to use this equation. Okay, because they want final velocity. Now S is 1.2, 1/2, 0 plus B times 0.77. So this becomes times 2 divided by 0.77 is equals to V. This gives me 2.4 divided by 0.77. That is 3.116. Approximately, I can take it as 3.12 meters per second. I hope it makes sense. Okay, so approximately my speed is around 3 meters per second. So we have proved that too. That's not difficult. Let's do this one. The final velocity calculated is the maximum velocity before the car slips off the track. So that means the maximum velocity it needs is around this much. If the maximum velocity goes beyond this, the car is going to slip off. Calculate the maximum horizontal force between the curved part of the track. Okay, now because it's a curved part in the question, it wants us to know something called as centripetal force, but let's not get there. Let's just leave this question for when we reach circular motion. Okay, don't want to confuse you, because some of you might be doing mechanics for the first time. The others who are revising it, they must be fine, but I'm just assuming that you're doing it for the first time, so we'll just focus on the straight line questions for now. Okay, all right, let's do this. A stone is dropped from rest. Fine. So stone starting speed is 0 down a well. Okay, so there is a well. The sound as the stone hits the wall is heard 3.5 seconds after the stone is dropped. So what would happen is your stone would hit this, and the minute it hits, a sound wave would travel up and would be heard after 3.5 seconds. Okay, which of the following gives the distance in meters traveled by the stone before it hits the water? How much distance would it travel? Say, what formula to be used? We have time around 3.5 seconds. The acceleration, which is downwards, vertical motion, which is gravity, 9.81 meters per second square. So I'm going to use S is equals to ut plus half at squared 9.81 times 3.5 squared. Okay, let's just see which one then. This one? Yeah, that's right. Okay, you can always pause and do it yourself. That's the whole idea. You have the question in front of you. I'm solving it for you, but you try and solve it before I solve it for you. Always pause, try to solve this question, play, see how I've done it. Match it if it's correct, learn from any mistakes that you might be doing. All right, the winner of a 400-meter race must have the greatest acceleration, average speed, instantaneous speed, maximum speed. Now, this is a little bit tricky question, so we need to understand what all these quantities are. The greatest acceleration would just mean that it would speed up and then would speed down. We don't know how fast is he retarding. Does it have equally fast retardation? Now, average speed is if it covers 400 meters in the shortest possible time, then his average speed is largest. So if that's what you want to cover a 400 meters race in a shortest possible time, without considering the fact for what part he was accelerating, what part he was decelerating, what part he was moving with constant speed. He will either accelerate or decelerate, but that's not the point here. If you want the winner to win, you want him to run the run in the you want him to run the 400-meter race in the shortest possible time. If the time is short as possible, that means the average speed for the entire journey should be highest. So you should have the greatest average speed. All right, let's see the fifth one. A coin is given a push and moves across the table. Fine, so there's a table. A coin is given a push. The coin is pushed again, but with a large force. The coin moves beyond the edge of the table and falls to the floor through a vertical height of 1.2 meters. So when you give a larger push, it will have a horizontal velocity and falls down. So it drops. Now, because it drops through a vertical height of 1.2 meters, I'm just making the diagram here. This is how your stone drops. While dropping down, it travels a distance of 1.2 meters. Because it is dropping down, okay, the speed of the car is 0.4 meters per second. So it leaves the table at a speed of 0.4 meters per second, and then it drops down. So what's happening? In the vertical direction, its speed is 0. And so this is my y direction. And then in x direction, the initial speed is 0.40, but it has no acceleration in the x direction. It has an acceleration of 9.81 in the y direction. So if I can calculate the time it takes, okay, let me just explain you how it is falling. Okay, let's just understand that first. Okay, we are here to learn, not solve the question. So now your coin is dropped. Okay, imagine there's no gravity. How would the coin, what path would the coin follow if there's no gravity? It will keep going straight, isn't it? Now, because there's gravity, it not only keeps on going straight, but it keeps on coming down too. So now it goes straight ahead, but it has come down. It has come down because of the gravity. After some more time, we'll keep on going down. Let's say this is the ground. And this is your table. That's a horrible looking table. Just bear with me. Say, and then here. So why has it traveled a horizontal distance? It has traveled the horizontal distance because of this speed, 0.40. Does it have an acceleration in x direction? No, because coin does not have an engine in it. It was given a push here. So the minute that push is gone, there's no force in the x direction. It has only a speed in x direction. So there's no acceleration in x direction. Then we don't know how much time it takes. And we don't know how much distance does it travel. So I'm going to just show you. This is the distance it travels in x direction. And it has come down by 1.2 meters. So now it has traveled, so because it has traveled like this, it ended up covering both 1.2 and x in the same time. So I'm going to try and use my equation in y direction. So s is 1.2, 0 plus half 9.81 t squared. So this gives me 2.4 divided by 9.81. Square root is t. Okay, so let's just figure out how much is that. So I have, okay, come on, move the rotation look. Okay, so I have 2.4 divided by 9.81 equal, so what I'm doing is I'll have to do a square root of this, and then whatever answer I get, I plug in to my x direction equation and then calculate the answer. Okay, so I'm just going to, so this is coming as 0.495 seconds. So my time is 0.495 seconds, and then my displacement is, so I'm now just using another color. Now in the x direction, ut plus half at squared. Initial speed in this is 0.40. and time will be this. I'm just for now leaving it. Acceleration is 0 because there's no acceleration in x direction. So the second term is 0. So 0.40 times 0.495, and that would be 0.40. So it's around 0.198 meters. So what this question has become, this has become straight line in both x and y. So it has become like kind of 2 dimensions. So one straight line, but in 2 dimensions, not in 1 dimension. So if you see the path followed by this ball is curved, but we have not solved this curve. What we've done is we have calculated the displacement both in y and in x direction, and then individually applied the speeds and accelerations in those directions. Right, let's just see the next one. A tennis player uses a racket to hit a ball over a net. Fine. The player stands 12 meters from the net. Okay, the ball vertically upwards and hits the ball at a height of 2.5 meters. So the ball is at 12.5. The ball leaves the racket horizontally. So the ball is leaving the racket with the horizontal speed of. Okay. The ball has a mass of this much. Okay, fine. The ball must land within 6.1 meters on the other side of the net. So 6.1 meters. So again, as you can see, now tell me, will this ball travel straight, or would it come down because of the gravity? It would, right? So it would come down because of the gravity. And we have to figure out that how much distance it has to come down. So that is fixed, 2.5. So by the time it comes down by 2.5 meters, can it reach up to 6.1 meters? I think that's the question. Hits the ground within distance. Okay, so now it has again become straight lines, but in 2 directions, both x and y. So I'm going to just divide. Okay, I'm just going to do it here. Wait, we want to see the question. Okay, so now y and x. My initial speed in x direction is 25. Now because it has a speed only in x direction, what's the speed in the y direction? Yeah, that's right, 0. What's the acceleration in y direction? 9.81. What's the acceleration in x direction? Does the ball have an engine inside? No, there's no force, there's no air resistance, no force, 0. Displacement in x direction is 2.5, isn't it? 25, 2.5. So S is 2.5. And then here, we have to see how much distance does it travel in the time that it comes down. So I'm going to use this equation here. So, okay, one hint, whenever you have these kind of questions, two straight line motions in x and y, the time remains the same. So the time you calculate from y can be used in x, or the time that you calculate in x can be used in y, because it's in the same time it is traveling both x and y. So S is now 2.5. Initial speed is 0. Half 9.81 times t squared. So 2.5 times 2 divided by 9.8 square root is t. So again, as I've told you, do not do the calculations to the last step, just leave it like this, and then apply the same equation in the x direction, ut plus half at squared. So S is, we don't know S, u is 25, time is this square root of 2.5 times 2 divided by 9.81 plus 0. Yeah, there is no acceleration. Because there's no acceleration, the second term would become 0. It's generally the case. If it's x direction, there will not be any acceleration in the x direction, because the gravity would exist only in the y direction. Okay, so if I'm using my calculator, this is giving me around 17.8 0.85 meters. That's my displacement. So total displacement is 17.85 meters, and this is coming as 18.1. So yes, we are falling in that range. Yeah, but does, because the distance is 18.1 minus 17.85, so we are falling in that range. Okay, that's why it's a 6 mark. Easy 6 mark, isn't it? That's the best way. I would, if you're getting a 6 mark, I would pray we get this kind of 6 marker, isn't it? Right, let's try this one. A ball roll along a table of length 0.83 meters. All right, lots of tables here. So table, a ball rolls, has a horizontal speed as it falls off. So when it falls off, it has a horizontal speed. So what do you think? Two straight line motions, isn't it? One y, one x. Okay. Which of the following is an expression of the, it hits the floor. So when it hits the floor, it has two, so this is, okay, so its x direction velocity would remain same, 1.72. But because it's coming down, it would have a velocity in y direction also, which is increasing every second the minute it starts falling off. See, my red arrow is becoming bigger and bigger. So how do I calculate this velocity, which is in y direction? What was the initial velocity in y direction? 0y, not x, y. In y direction, the initial velocity is 0. Finally, we have to calculate the distance in y direction is how much? 0.83. All right. So I'm just going to use v square equals u square plus 2as. 0 to 9.81 times 0.83. Now, as I can see in my options, they do not want my final answer, they just want the numbers. So my v square is 2 times 9.81 times 0.83. Now what it wants is with what velocity it hits the floor. So the minute the ball hits the floor, it has two speeds, 1.72 and v. Now it has become now a vector equation. So it's a resultant velocity. So the resultant velocity will be along this, and the resultant velocity will be square root of v squared plus 1.72 squared. Pythagoras, 90 degree, they both are at 90 degrees, so the resultant will be this. Now r will be under root of v square is this, 2 times 9.81 times 0.83, that's my v square, plus 1.72 squared. What kind of option is there? I think this one. Yeah, that's the answer. Yeah, so we're not squaring this. This is already squared. This v is already squared. That's what they want to check. Can they focus? Yeah, do not make errors. Right, let's do this one. A vehicle that skids. A vehicle that skids. Can I leave a mark on road surface? Skid mark I used to calculate the velocity of the vehicle at the start of the skid. At least at a test, a track car of mass this much was collided into the back of a stationary car of mass this much. So I'm just drawing a little bit diagram. You know, it just helps my mind to focus. So this is colliding at the back of a stationary car. So I have, this is 1500 kg, this is 1200 kg. Okay, the two cars skid along the road together, leaving a skid's mark of length 7.5. So my S is 7.5. The cars decelerated at this much to stop at the end. So my final speed is 0. Acceleration is 5.6. Oh, this is easy, isn't it? So they're asking the starting. At the start, what is the velocity of the two cars? Now here, it is actually a little bit tricky. So because it's asking you the okay, I'm sorry, I got confused. No, it doesn't want you anything else except the initial velocity. So I'm just going to use v square equals u square plus 2as. This is 0, u square plus 2 times 5.6 times 7.5. And because it is minus, it's deceleration. Just doing that correction here. So this becomes minus. So my u square is 2 times 5.6 times 7.5. And then you take square root both the sides and you get the initial speed, which is coming around. Give me a second. Okay. Fine. So it's coming around 9.2 meters per second. So it is around 9 meters per second. So we got that. Okay. A ball was dropped from rest from a height above the ground. Okay. The ball bounced up to a half its initial height. Which graph shows the velocity varying with time? Okay. Let's just try and see what's happening. So when the ball is falling down, let's say it falls down from this height, h. So what's happening to the speed? Is it increasing? It is increasing. So it could be this, could be this, could be this. Not this. Okay. So the speed is increasing and then it hits the surface and loses some of its energy in the term of thermal energy, elastic energy, and then bounces back up to only half the height, h/2. Okay, so because it is bouncing back up, now is the speed changing? Is the speed reducing? The speed is reducing, and when it reaches at this top position, the final speed will be 0. So I need the final velocity to be 0. So it could be this, it could be this, it cannot be this. Why it cannot be this is, see in this one, it is starting with the positive velocity and the positive velocity is decreasing. So that is not happening. It cannot, positive velocity cannot decrease. So because it's changing direction, we have to change the direction. Here, if I'm taking my velocity to be positive, here my velocity will be negative when it's going back up. While coming down, if it was positive, while going up, it will be negative. So it cannot be in this case. So either this or this. Now which one? So obviously this is so exact in shape. You have to figure out what would be the right kind of graph. So now if the height is halved, what would happen to the velocity? What would be the ratio of the velocity? So you have to figure out which exact graph. That means because they're so close, we have to do some calculations. We can't just take a fluke and a guess. Okay, so what I'm going to do here is, what's the relationship? Which velocity relationship I'm going to use? I'm going to use this. Okay. So because what is the relationship between V and S? This. That means my V is proportional to square root of S. Now, that means if your S becomes half, that means your velocity would become 1 over root 2, isn't it? So 1 over root 2 is 0.7. That means when your distance is halved, your velocity becomes 0.7 times the initial velocity. So if the velocity was 10, this velocity would be 7. So if this is 10, this cannot be 7, isn't it? It's 2 less. Do you get my point, what I'm trying to say here? Okay, let's just redo it. Let me just clear this. Okay, so we've just now figured out that either A or B is to be is our answer. Now the question says it bounces up to half the initial height. So if the height it is traveling is halved, the distance it is traveling is halved, what must be the velocity? So the velocity is now proportional to the displacement, square root of displacement. So if displacement is halved, the velocity should become 1 over root 2, and 1 over root 2 is 0.7. You can do that in your calculator. So because it's 0.7 times the initial velocity. So if the initial velocity was 10, this could be 7, 10 and 7. So if this height is 10, this height cannot be 7. This height is 10, this can be 7. So A would be your answer. Okay, pause, redo it. Do not ever move ahead till you understand a question. Okay, another one. Similarly, let's just see. A basketball is dropped vertically onto the horizontal ground and bounces twice before being caught. Okay, so there's a bouncing ball, bounces twice, one and then twice, and being caught here. So now here, see, so okay, I don't want to confuse you by giving you this diagram. I'm going to give you the same diagram. So it's bouncing from here, bounces back up with a red line. So this goes, oops, come on, give me the red color. So it goes up, comes down, okay, comes down again, and then because it has further reduced velocity, goes up to yellow. So the speed is decreasing, and then it's caught. So 2 times it has bounced, and every time the speed is decreasing. So how do I know? I know from this graph. Let's see. So it is dropped. The first time it is dropped, this 0 speed, and the final speed is somewhere around, let's just see, what's this value? This value here. So 3 to 4 is 10. So 1 divided by 10, each line is 0.1. So 4.1, 4.2, 4.3, yeah? No, there is some problem here. How much is 1, 2, 3, 4, 5? Okay, sorry, 5. 1 divided by 5 is 0.2. So 2, 4, 6. So 4.6 meters a second. And then it hits the ground, and because of contact with the ground, because of losses, thermal energy, elastic potential energy losses, blah, 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 what happens is its speed reduces, and its speed reduces to now what? This is 2.2, 2.4. Okay, so now it goes back up. It hit the ground with 4.6. Because of loss of energy, it now goes back up with 2.4 meters per second. And then because it's rising up, speed is decreasing, final speed becomes 0. And then it starts coming down, speed starts increasing, but in the negative direction, and reaches 2.4 again, because it is still in the air, isn't it? So there's no losses in the air. Only when it touches the ground, it loses its energy because of thermal energy and elastic potential energy, because the shape changes and deforms. So now 2.4, it hits the ground again with 2.4. So it hits with 2.4, and then when it bounces back, its speed would be less than 2.4, and as we can see from here, okay, so this, so 2, 4, 6, 1.6, so it bounces back up with 1.6 meters per second. Do we understand the question? So see, one question can teach you so many things what the concepts would not teach you. So always try to learn what the question is trying to teach you. Do not be in the hurry to get the final answer. Just give me the answer already, or just give me the mark scheme. No, we're trying to learn from every single question. Have you got this part? Fine. If not, pause, rewind. Yeah, you know the drill. Now, suggest why the downward sloping lines are all parallel. Now, why this line, and this line is parallel? Now let's go back to the concept. What does the gradient of VT graph gives you? Or why is it decreasing? Who's decreasing it? Or who's increasing it? Acceleration? And is the acceleration or retardation the same in all the 3 cases? How much is that? 9.81. So what's your answer? Because constant acceleration. There you go. See, very smart. They're very smart. Same question. They have just given you such a beautiful question to check whether you understand what's the meaning of acceleration or constant acceleration or not. Now let's see. State the reason for the upward sloping dotted lines. So why is this? So do you see? From here, this is an upward sloping. So there's a slight slope in these lines. There's a slight slope in these lines. Why do these lines have a slope? What's happening at that slopes? So it's when it's exactly at the time when the ball is touching the floor and then bouncing back. So what does that show? That shows the force of the floor. Okay, it's the time when the ball was in contact. It's a very small time. That's why, see, this is a very small time, very small time when it was in contact. Just touches and bounces back. Only the time when it was in contact. So it talks about, the reason is the time for, it talks about the contact of the ball with the floor. Describe how the gradient of the dotted lines would change if the basketball was not fully inflated. What do you think? Would it be able to bounce back as quickly if it is not fully inflated? It would not. It would have less force. Would it have more contact time? So if it had more contact time, see, I'm just going to draw it here. This is one slope. It's going up from positive to negative or negative to positive. And suppose if it is not inflated, would it take more time to go here? So what's happening to the gradient then? It would have more time. So this is more time. So it'll have lower gradient. Okay. Calculate the initial height through which the basketball fell. Say now, from what height is it falling down? So we know our speed is somewhere around 4 point. Now I need to be very exact. Okay. Let's just clear it because I think. Okay, come on, connect. So this one, oops. Okay, it refuses, the eraser refuses to pick up. Oh, come on. No. Okay, so we just need to be very exact here. How much? Okay, I'm just going to try now. Yeah, here we go. So, because, you know, any error in our reading would bring error in our answers, and then we would end up losing the marks. So as you can see, this W point is between 4.6 line and 4.8 line. So I'm going to take the speed here as 4.7. Okay. Okay. Now where are we going? So the speed is, the final speed is 4.7 meters per second. It was dropped, so initial is 0. As you can see from the graph, the initial speed is 0 here. Okay. And you know the acceleration is 9.81. So I can just calculate using plus 2as, 4.7 squared, 0 plus 2 times 9.81 times s, and that would give me sorry, 4.7 squared divided by 2 divided by 0.81. Okay, so I'm getting the answer to be 1.125. So I'm taking it as 1.125. Significant figures, 1.313 meters. That's it, done. Show that the kinetic energy of the basketball at x is about 1 joules. Where is x? That's my x. We know the speed at x is around 2.4. Let's just check. I don't want again to do the mistake. Is it exactly at 4? Yeah, exactly at 2.4. So, okay, now kinetic energy. Even if you had not done the energies yet, we know the formula from our earlier classes. Half mv squared, half 0.4, 2.4 squared, which is around if I just plug in the values, I'm getting the answer as 1.15 joules, which is near to 1 joule. Perfect. Now calculate the height of the basketball at y. Where is y now? Okay, so that's the point. So that means it has reached this point where the velocity is 0, isn't it? So how is it going? So your ball is hitting the ground. Okay, it's a quite confusing question. So I'm just going to redraw the diagram to help you understand. All right. So what has happened here is a ball is dropped. It hits the ground with 4.7 meters per second, bounces up with 2.4, reaches some maximum height, and this height is y. So this height it wants. How do you solve it? You know kinetic energy here. Can you convert the kinetic energy to potential energy? Just use that. Ke is equals to potential energy, or you can use, okay, I just got carried away by energy. We just calculated kinetic energy in the previous question. That's why my final velocity is 0 here. Initial is 2.4 squared. Acceleration, now because it's going up, my acceleration is basically acting like retardation, minus 9.81 into s. Okay, into s. So this is 2.4 squared divided by 2 times 9.81 s. Okay, this becomes 2.4 times 2.4 divided by 2 and then 9.81. So my answer is approximately 0.29. So the height is 0.29 meters. So it goes up to a height of 0.29 meters. Okay, I hope we got it. So it's a simple question. That's why the marks are not very high in each question. But collectively, small steps, one question at a time, and then proceed. The velocity of the basketball on impact at W is greater than the velocity on impact at Z. Let's see, W, where is W? This is Z and this is, okay, so Y is the velocity on impact at W is greater than the velocity on impact at Z. Why? So on this impact, the velocity has changed from 4.7 to 2.4, and in the second impact it came down with 2.4 but went back up with, how much was that? Somewhere here, isn't it? That was 1.6. Why? What's the difference? What is the reason for this difference? It's because elastic potential energy or transfer is the elastic potential energy of the basketball is wasted as thermal energy, or energy is lost as heat. Anything you can just asking you where is the energy going. So that's all you know. Okay, let's do this one. A simplified VT graph for the flight of a drone is shown. So before going here, let's see what's happening. What's happening to the velocity here? Constant velocity. So what does it mean? Acceleration is 0. Even here, the velocity is constant. So acceleration is 0. So now let's see what it asks. Now it's asking displacement time graph. So my velocity is constant. The displacement graphs have to be straight line. So it clearly cannot be this. It'll be either this or this, definitely not this. Why not this? Because the time is constant and the displacement is decreasing. What? That doesn't happen. Time can never be constant, isn't it? Okay, so what's happening here? Which one? So this one is positive gradient. this one is negative gradient. So which one has a positive gradient and which one has a negative gradient? So this one is a positive gradient. Yeah, this one is negative gradient because decreasing. What about this? Positive. But what about this? This gradient is also positive. It's increasing. So it's a negative velocity, negative displacement. So think of as a -2 becoming 0. This is a positive gradient. This is 2 becoming 0 or 2 becoming 1. So this is a negative gradient. So only this is right. Positive gradient, negative gradient, positive gradient, and possible, not possible. Okay, let's do A's answer. Next, what's happening to here? Velocity is increasing, but the gradient is constant. That means my acceleration is constant. Velocity is constant. Velocity is not changing. See, it's the same velocity. So acceleration is 0. Okay. So for my second part, this part, so I'm going to just draw here. Displacement varies with time. So how do you draw? If your acceleration is constant, that means the velocity is increasing in equal intervals of time. So my displacement graph would be a curve. And then velocity is a constant, so it will be a straight line. Something like this. Yeah. So let's just see. Not possible, not possible, not possible. What do you think? Not possible, we have to have a curve. Not possible, could be. Because in both the paths, displacement is a curve. But see what's happening here. Is displacement changing when the time is changing? It's constantly at one displacement. This shows the velocity is 0. Is velocity 0 here? Velocity is not 0, it's just constant. So the velocity is constant. That's the winner. Okay, all right, let's just need the next one. A ball is dropped from a height of 1.3 meters. The graph shows how the height above the ground varies with time for several bounces. So it is dropped from what height? 1.3. After the first bounce, the height is reduced to something 1 point. Okay, so I have 10 lines between 1 to 1.2. So 0.2 divided by 10, 0.02. Say 1.02, isn't it? No, 20 divided by 10. Yeah, I'm right, isn't it? Yeah, that's right. Okay, so this one is 1.02040608. Okay, yeah, that's right. 1.02. Okay. Again, it has reduced and so on. Let's see what the question is asking. At 2.6 seconds, the magnitude of the displacement from the starting position. 2.6 seconds. Where is that? Okay, I need my specs. So I have, what is each line worth? So this is 2.5 and this is 3, isn't it? So 10 lines, 0.5. 0.5 in 10, 0.05 each line. Yeah. And then I'm 1 line short of 3. No, I need 2.6. So 0, 5, 0, 2.1, 2.15, 2.2, 2.25, 3, 3, 5. No, sorry, we're starting at 2.5. Oh my god. Okay, so 2.55, 2.6. So this is where here. So 2.6 here. Here is 0.6. So the height it is 0.6. Say my ball started from 1.3, but is now at 0.6. This is 0.6, and we started at 1.3. What is it asking? The magnitude of displacement from the starting. So how far it is from starting position? Minus 0.6, that is 0.7. That's the answer. Reading the graph, that's it. Okay. Okay. A ball is dropped from a height of 1.3 meters. Oh, do I have the same question? Looks like same. Oh. How can the velocity of the ball at t equals to 2.5 seconds be determined from the graph? So if I want to find what's the velocity at 2.5 seconds, this point, how do you do? It's a displacement time graph. How do you find velocity? Using gradient. Yeah. So draw a tangent and calculate the gradient. That's it. The graph is a displacement time graph for a runner. Okay, say it's curved, that means it is accelerating. Straight line means constant velocity, and because it's curved downwards, that means it is decelerating for the final part. It would seem so, that's how it might do. The velocity of the runner at 5 seconds is approximately, there is a 5 seconds, so this is the 5 seconds, somewhere here. Okay, so we draw a tangent. Okay, so I'm just going to take this straight line and join here, and I'm going to take it from here. Okay, all right, so I should get somewhere around 40, because I do not have a ruler here, so it's kind of like you draw the tangent, or you can take as big triangle as possible. So let's just figure out, can it be 8? At 5 seconds it has reached 40, but remember it was accelerating, so it cannot have 8 meters per second. It will have a larger average velocity for the 5 seconds, so that's not right. Sorry, it doesn't want average, it wants instantaneous velocity at 5. Say cannot be 8, cannot be 9. So what is 40 over 3? Is it 3, 3, and 9? So somewhere around 13. So that would be my answer, 12 meters per second. What you can do is, you can draw you can just complete this straight triangle and just get the gradient at this point. So what we're doing is height versus the rise over run, or y over x, and then you get the answer. All right, so far I think, okay, we have more questions. Okay, I think we're going to do the next questions. Let's see how many questions are left. Okay, we have only one. Let's just finish it. I thought we'll just do it next class, but we can't finish it. An object from the rest moves from rest. The graph shows how the acceleration varies with time. So acceleration is changing, but it's changing constantly here. Constant increase. So so now this one would mean my graph would look like this, because acceleration is constant. This one is increasing gradient, so this is increasing gradient, increasing acceleration, and hence this would be right. Let's see this one. So this is, as you can see, if I do different tangents at different points, the gradients are decreasing. So if I want to draw a graph for this one, so acceleration would be decreasing, something like this. Let's see this one. Velocity is constant, not changing. So my acceleration would be 0. So if I draw the graph between acceleration and time, it would be something like this. The graph questions are easy, but they're confusing because we're not used to doing questions on graphs. In your earlier classes, mostly if it is science, you will be doing questions which is just plug in the values and solve it. Graph requires a little bit of analysis, so they look like the most difficult questions, but they are actually the easy ones. They are your easy quick marks, right? So thank you for watching. Keep learning, and if any part of the video you don't get it, just revise, just pause, go back, redo it. In fact, redo the entire paper once again and see if you don't get it. Next class, we will try and start projectile motion. Is it? Thank you.